Given an integral from 2 to 6, f of x dx is equal to 10. And integral from 2 to 6 of g of x dx is equal to -2. We want to find the following. So the first one is from 2 to 6, f of x plus g of x dx. This one is the same thing as just splitting this up into two separate integrals. And then all you have to do is just replace, okay, the first one with 10 and the second one with -2, and you get 8 as your answer. For part B, here you have to subtract. So it's the same process. You split up into two separate integrals, but to save the time, all you do is take the first integral is 10, and then minus the second integral is -2. So that's just going to give us 12. For C, we have the integral from 2 to 6 of 2 times g of x. Because 2 is a constant, I can factor that out. And so this is equal to 2 times the integral, which is -2. So my answer is -4. For part D, I have the integral from 6 to 2, f of x plus 2. This one, I can rewrite it as 2 to 6, but when I flip the limits, I have to put a negative sign in front. And now I can break this up into two separate integrals. The first one being f of x, the second one being the constant 2. So the integral from 2 to 6 of f of x dx, that was given to us as 10. But now the integral from 2 to 6 of 2, that's just taking the function y equals 2 and then finding the area from 2 to 6. That's this thing right here. This is a rectangle base 4, height 2. So that's going to give me 8. And so final answer is -18. All right, now we're given different integrals. So we have integral from -1 to 1 f of x dx is 0. And then integral from 0 to 1 is 5. So part A says find the integral from -1 to 0 of f of x dx. So a good way to look at this problem is using a number line. If the area from -1 to 1, if this whole thing is 0, 0 to 1 is 5, how much does -1 to 0 have to be? So this is like the part plus part equals whole. It's like part plus 5 equals whole, which is 0. That means the part has to be -5. Right? -5 plus 5 gives me the whole thing, which is 0. So this thing has to be -5. For part B, we have -1 to 1, and then absolute value of f of x dx. So from -1 to 0, we know that's going to be negative. So really, we're going to multiply that area by a negative to make it positive. And then the area from 0 to 1 is going to be positive now. So we'll leave it alone like that. So it's like -5 plus 5. This will give me positive 10. Now for part C, we have the integral from -1 to 1 f of x dx minus the integral from 1 to 0 f of x dx. This one I'm going to rewrite it, but first, -1 to 1 is 0. That's already given to us. And then now I'm going to switch the limits here. So when I switch the limits, I'm going to put a negative in front. So there's going to be two negatives here. Two negatives give me a positive, and then the area from 0 to 1 is 5. Now lastly, for part D, we have integral from -1 to -1, f of x minus 4 times f of x squared times f of x. Well, this looks crazy because we don't know what f of x squared is. So you can't use any of the properties above, but what you have to use is the fact that you're taking the area from -1 to -1. Think of this as your x, or in other words, your base. And think of this inside as your height. Okay, if the base is 0, I don't really care what the height is. This is going to be 0. So whenever you have the limits here being the same, the area is always going to be 0. And that is my answer.